Alright, so let us now look at what other applications IoT can provide for socio kind of a socio technical problem that IoT can sort of solve. One thing is, if you look around us, and every day you read newspapers, you realize that people are dying for so many reasons. Okay, it is possible that there is a cylinder burst, people die. There is a fire inside a home, people die. There is a bad dilapidated building, it collapses or partially collapses, people die, right. And many people have not been rescued because the rescue operations did not come in the first place in early time, as quickly as it should have. So that could have also that is also a cause for more deaths than what would have normally occurred. I think IoT can play a very important role there, and essentially try to solve try to provide a solution, assist in providing a good solution. This prompted US government to start what is known as an independent network called the first responder networks. The first responder networks are typically clubbed with what is known as a tactical network. So, I think we should not be mixing the two, let us keep it just to first responder networks. Essentially, first responder networks primary objective is to save lives in buildings, in homes and so on and so forth when there is an outbreak of some sort of an incident. It could be fire, it could be some other reason why inmates in the home cannot come out. There is perhaps a personal attack on them by some individuals. So anything can happen. So these people are supposed to go there, these first responders are expected to go there and rescue human life, bring human life out. Now if it is a large building, there is an issue of knowing where there are humans, that is people who are trapped, and first responders themselves have to go inside, isn't it, and they have to rescue people. So whoever is controlling this operation of rescuing people has two problems on hand. One is to know where humans are trapped. Second problem is, where are these first responders who have entered the building to rescue them. Okay, so both are so it's a two kind of a problem, and first responders, once they enter the building, they require a lot of help and guidance from people who are managing the rescue operations from outside, to be told what to do, whether they should proceed or not proceed, or whether they should come back and take another turn and go and look for humans there, anything. So you need that full orchestration mechanism to be in place before you actually rescue anything. Therefore, it goes back to what, in terms of any course of that nature, goes back to a very important thing, which is localization again. And this time you have to localize first responders very accurately from outside, and you should be able to guide the first responder to a few things, to a few locations, and accordingly help the first responder to rescue the humans who are trapped there. So this brought the whole issue of the problem of developing, or to develop, the country should develop a fantastic technology which caters to the local needs of people depending on the architectural styles of different buildings, and be able to accurately localize the responders first, so that they can in turn save humans inside the building. This is a very important area of research which have the indoor localization problem is a very important area of research when it comes to first responder networks. So, I can say first responder networks relate to localization. Okay. Although we did a course on localization, modules on localization, it was not approached from the problem of trying to build a first responder networks, but this is important. This is a hard problem. Again it goes back to say what is a good technology that essentially will sort of help us to build a good accurate way of precisely locating first responders inside a building. Alright, there is a technology there which has come out from NASA, and that technology is called Pointer. I want you to look this up, Pointer, to get you a feel of how sophisticated algorithm one can have in trying to localize these first responders. It is not just about localization of responders, other thing is you need detectors, you need detection of human life, right. You need detection of human life, which means you need sensors which sort of sense people under a debris, for instance. Okay, somebody is buried under a debris, but just the hand is out, or only the leg, one part of the leg is out. This is in a situation where there is a building collapse or a partial building collapse. The human is alive, but you want to know where the humans are in a heap of debris, and you are looking for human life there. So, you may want to look for certain signatures which are available for which can accurately say that there is human life under the debris. Several I would say RF techniques are available. Okay. RF techniques are available, RF and microwave techniques are available for detecting. You extract signatures from the RF signal to come and say that to conclude that indeed it is there is a human or no human. Advantages: it is non-invasive, you can do it from some distance, and you could essentially go after, once the signature says that there is human life, you could go there and rescue people. But that is just one way, it is an expensive technology, and IoT definitely will look for other alternatives. If it is IoT solution, we look for alternatives. One other alternative is related to thermal sensors. Okay. When I say thermal sensors, these are heat sensors which detect heat radiation coming from human body, and they are so they can absorb this radiation, and sort of you can run some simple algorithms to conclude that there is a human or whether it is something else. Because when you talk about heat and heat IR radiation, several objects, you will be surprised that if you put an IR sensor, the thermal map may be very prevalent even if there are no humans inside, because several objects give away this IR radiation. Sometimes tables, chairs and so on, they will all give you a lot of clutter, and it could be just that when the building has collapsed and a fire is ignited at some point, that fire heat itself can overwhelm the IR sensor and detection can go completely astray. So, you have to be careful about your design of algorithms, and therefore thermal sensors are good, but you will have to take care of this these what shall I say, a lot of false alarms which come by just the heat radiation. So, you can look at them. There are array of thermal sensors available. You have 4x4 thermal sensors, and then there are 8x8 thermal sensors, and one can move on to higher array of sensors, and these sensors can essentially detect human life. Well, we tried a little bit here, and I do not have a mature solution at the moment, but it is definitely something that you can try. The good thing about these thermal sensors are 4x4 or 8x8, they are low in energy consumption, they are small in size, they can be mounted on any small sort of a bug, right, and then install put inside on install it on the bug and let the bug, battery driven bug, go inside and sort of get hold of the thermal map and use the data for analysis of humans or otherwise. So, these are things that are very much possible. A third possibility exists, that the building already has, whichever building is under attack or building is under fire or whatever, has some sort of camera sensors already, because nowadays applying video cameras there is quite common in several buildings, and this camera sensors can aid giving you pictures, live pictures in the event give live pictures to these first responders. But the first problem that will come is, how do you trust this, how does the camera system trust the first responder that he or she has come to rescue them and therefore share the pictures. So, that indeed is really a problem. So, I mentioned to you right on day 1 that you will be talking about first responder networks and you will be saying how to save human life and all that, but very soon we will get bogged down to technologies which will enable such things, and often it is these technologies which can sort of be a big hurdle in succeeding and coming out with a very good first responder solution. Okay. So, sometimes it is the other way, there is a very good technology, but there is no proper use case, and in sometimes there is a very good use case for application, but technology does not allow you to apply it in a free and fair manner and transparent manner and in a trustful manner. Trust has become a major issue. Why should a camera sensor share its data to a first responder without knowing who the first responder is, right? We as humans know that so and so is the first responder, but how does the camera know? So, here is a problem. This all brings us to some new things which are coming up in the area of first responder networks with IoT there. Security of the solution becomes very, very critical. Therefore, here I would say building camera sensors, but security solutions, security has taken a forefront of everything. Now, I will point you to something that has come up recently just to answer this problem of security, and that is related to what is known as SDP. It stands for software defined perimeter. Okay. This is a very nice framework which is coming up in a big way, and that will allow because you have a software defined perimeter, you have the ability to add you have the ability to add devices in a secure manner, and therefore you will be able to share data rather in a secure manner. Okay. So, you have devices to be added and sharing of data. Traditionally, if you look at IoT and security, while there are so many possible solutions that people talk about, cryptography itself is quite mature, but crypto analysis is something that people continue to find it exciting. There are a lot of challenges in crypto analysis, breaking keys and so on. but cryptography itself I do not think any major changes have happened in the last 1 decade. The same set of algorithms are popular, and it is only where crypto analysis where there is a lot of challenges, what kind of compute you require, what kind of algorithms you require even to break keys. So that is what people are putting effort on. And of course I mentioned to you that devices, device identity, unique ID, generation of unique ID, these are harder issues which IoT should try to in the IoT framework we have to try and solve them if you want to look at first responder networks and so on. Traditionally IoT devices cannot be in, let us say in a secure part of a network, it cannot be, because it is looking for services or it is offering services. So all of them will have to be outside the other side of the firewall, right, and therefore there is always the risk of IoT devices being attacked and some sort of cyber attack on these devices and all that. Given that situation, how will a camera sensor which is also an IoT device can actually fall into this framework? That is where SDP comes into the picture, and I have a nice paper which was written some time back and published in the IEEE, and I thought it will be best if I describe that paper. So let me expand this to 200%, 150%, 200%, and then let us see what they have to say here. Look at what is written here. It says already, imagine a first responder arriving at an incident site, and the person is wearing some advanced communication technology, wants to and there is a crisis, and you begin to talk to first responders on their handheld screens or wearable goggles. Right, and they are conversing amongst themselves, okay, and then there is they are in a, so there are many critical systems in the building or even people who are there in the building, and they have to identify themselves. These people have the problem that they have to identify themselves accurately, properly, before any data can be shared from the building, alright. So these are all essentially falling under the machine to machine framework, and so they have to, these camera sensors have to talk to those systems which are those handheld devices which are held by these first responder humans, and security keys have to be exchanged and they have to be trusted, and then only then the data can start coming out. It need not be just the data part, it can also be that there are once you trust, you want to open close doors, you want to shut down ventilation systems, you want to open fire suppression equipment, several things including video surveillance cameras which may want to send a critical live feed. All of that should happen once these responders come there, and things should happen automatically and in real time, right. Only then any of these IoT technologies are actually going to be very useful. As I mentioned to you, all these devices which are part of the building have to communicate to devices which the first responders are carrying, and all of that should happen seamlessly, meaning it should be M to M. Okay, so it should be machine to machine communication, and there are several IoT protocols which support M to M communications. So let us not get into that. Alright, so here we have the situational awareness that responders, it should have the connectivity automated with M to M network technology. Responders would have much improved situational awareness, and therefore they can focus on rescuing humans, and therefore Internet of Everything is a key driving part here. Now if you want to do all of that, we will skip this M to M part, because that is something that people have all, I think other courses would cover that. So let us just look at the requirement for SDP, which is the software defined security so software defined parameters framework. So here it says that is essentially it is going to be like a big game changer for machine to machine internet of things because of the following reason that if you look at all IoT devices that are there, they will all be in the 20-30 billion devices that are likely to come up. Each one of them will have an IPv6 address, that means they are easily addressable from anywhere on the internet. So security is really an issue, and if you look at network security, if you look at firewall and all that, every device which is an IoT device has to lie outside the firewall and essentially getting exposed to internet hacking and all that. So there is no way by which you can do both, expose an IoT device as well as keep it inside the firewall. It is not going to happen, that is not going to be easy. So you will have to find out a way and to expose the device and yet keep it secure. That essentially means you must do hide in plain sight somehow, and SDP is really an answer for this kind of hide in basically hide in plain sight. So what is the framework under which SDP works? It is just not so let us look at that part very carefully. Look at what the sentence says. With SDP you can deploy an M2M device network that is not dependent on physical network infrastructure layout. Just use SDP to gather the desired IP addressable M2M devices into a secure logical network. Okay. So as long as M2M devices can achieve internet connectivity by any wired whatever be the method, they can be configured into the secure SDP network, and once the first responders devices, set of devices which form a network and the building infrastructure devices are part of the secure network, then several things open up for people for first responders to actually save people inside the building. So this SDP framework will allow you to do all of that. It gives you an example. If a mobile M2M device geolocates within range of an SDP M2M network node, it can provide appropriate SDP authentication credentials, and it can dynamically join the network. What this means is that the proposed vision of the emergency responder walking toward a smart building that have buildings occupant sensor starting communication with him her can be achieved with SDP networks. SDP has already been demonstrated as an operational concept, and with a M2M SDP approach it becomes irrelevant which type of network communications you are actually talking of. So it is agnostic to any link layer technologies out there. All of them can be leveraged to create M2M IoT network with as many individual secure SDP subnets as needed. So how does it all work, and how does this critical functionality come about? You can see that network access authorization workflow is shown here. There are two types of channels here. The dotted line indicates the control channel, and the thick line indicates the data channel, and there are numbers here. You see the SDP controllers. So let us pass through this 1 2 3 4 5, which will essentially give you an idea of what is what exactly plays out here and then 6 7 essentially being the last two steps, 7 actually being the last step towards sharing the data. First is the SDP controllers. Controllers are all, several of them are online, and there are accepting SDP hosts. Okay, so you can see accepting SDP host is here, one of them is here and the other one is here, right. Both of them are accepting SDP hosts, and they are essentially registering with this SDP controller, and then what actually happens is there is an initiating SDP host. This could be like a first responders device which wants to connect to the building network. So, there is an initiating SDP host that is also on a dotted line. Once so this happens 1, 2 and 3 happens, 3 is actually mutual TLS to controller. So, everything is based on transport layer security or TLS to the controller. 4 essentially means that list of authorized accepting hosts are determined at the SDP controller. There are many who may not want to become accepting SDP hosts, but there is nevertheless a list of authorized accepting hosts which are determined. And then 5 is accept communication from initiating host, that is, this is the initiating host who wants to connect to these 2 accepting SDP hosts, and now that SDP controller has given the list, now it knows that the IP addresses are now available, right, at the initiating SDP host. So, receive list of IPs of accepting hosts, and then the initiating IP SDP host directly contacts the accepting hosts with these thick lines, which is essentially for gathering data. So, till such time the SDP controller initiates everything and makes available the IP addresses, the initiating SDP host cannot get data from any one of them, and that is essentially establishing all these mutual TLS tunnels between SDP host and accepting host and all that, and only then data can flow. You can see now we moved away from first responder networks to a framework which is meant for secure transfer of data between initiating SDP hosts and accepting SDP hosts, which is quite strange that why did we move away from an application into something which is very specific to a protocol framework and so on. But this is not correct if you think that way, because if you want your first responder network to succeed, whatever solution you are trying to put, you have to co-design with security, and this is a framework, and I thought it more relevant for us to describe SDP here rather than in a security module, right. So, please co-design your first responder solutions with security built into that system is a classic example of how you need to do co-design of any solution. So, that is the reason why this part comes up here.